Hello everyone. Today we are discussing this question. This question is basically, I have divided the entire video into three parts. The first part I would be explaining the question, and the subsequent two part would be explaining the two concept of it, and then the last part would be the coding solution of it. So this question is simply sum of the distances from one node to all other nodes. So let's say one example. The distance from node 1 to node 4 is 2, 1 and 2. Okay. Then distance from 1 to 5 is 2. Distance from 1 to 3 is 1. Distance from 1 to 2 is 1. So if I add all those distance, it would come out to be 6. So distance from 1 to all the rest of the nodes is 6. Similarly, distance from 4 to the rest of the node. So 4 rest of the node would be 8. You can count it. 4 to 3 is 1, 4 to 5 is 2, 4 to 1 is 2, and 4 to 2 is 3. So you can count it. So finally the output that we require is 69588. That is the distance, sum of all the distances from node 1 is 6, sum of all the distances from node 2 is 9, so on. Yeah, for finding the solution of it, I just wanted to discuss uh, two basic concepts that is used to solve these questions. In this in this questions, we just have to solve what is the sum of the distances from one node to all other nodes. So the basic logical part is you have to count the distance from one node to the other node and do the same for all the rest of the nodes. Okay. So you see this concept. I have a root node U and it has some child nodes C1, C2 and Ck. And C1 has again the child nodes A, B, C, D. Okay. So what we see is A distance from C1 is 1, B distance from C1 is 1, C distance from C1 is 2, C distance from C1 is 2. Sorry, D distance from C1 is 2. So you can see distance from C1. I'm counting for A it would be 1, for B it would be 1, for C it would be 1 and 2, for D it would be 1, 2. So this is with respect to C1. Now if I tell you what is the distance of C from U. So distance of C from U would be 3. You can say 1, 2 and 3. So these are the distances. I have wrote it down. So the thing that you can notice is every distance get increased by 1. Every distance. 2 got 3, 2 got 3, 1 got 2. So the distance from U to all the nodes inside it in this path would be distance from C1 to all the nodes plus the number of nodes. In this case, you see the total sum is 6, and when I take from U, then it is 6 plus 5. 5 is the node 1, 2, 3, 4, 5. It would be 11. Now the total sum is 11. So I can write a generalized formula that sub of answer U is equal to sub of answer of Ci plus nodes of Ci summation 1 to k. I would do it for all the C1, C2, C3, C4. So that is the basically a concept basically. Okay. In this case, we only discussed the distance from U to all the nodes that are present in U. So it is the distance from U to all the other nodes. It would be C1, C2, it would be in the path of C2, Ck also. So those are the distance. But the final solution that we have to find is we don't have to calculate it for U only. We can calculate it for B also. From B, all the distances, sum of all the distances from B to all other nodes, whether those nodes can be the upper part of it, those nodes can be at the below part of it as well. So we have to calculate that also. So for calculating it, if we know this formula gives whatever there is in the lower part of that particular node. So for U, this formula would give what is in the lower part of U. So similarly, if U is something like C1, so it would give the lower part of it, like answer for C1. So whatever is in the subtree rooted at C1, it would not give answer for these parts. These would not be counted. So if because this can go downward and this can go upward also, because there are nodes which are up in their hierarchy as well. So for calculating that, we use the same technique that we used above. What we do, what we do is, so let's say Ci. Ci is a node and it has a two child node. Okay. So if we have to calculate for Ci, we know that whatever nodes in rooted at whatever the nodes that are in the subtree rooted at C1, we know the answer from the above one. From the above just I showed, that is the answer. For whatever would come, that would be answer. But from C1, it can go to 1, C1 to CK, C1 to C2. So these did not got calculated. So for calculating that, what we do is we reverse it. So now these two black ones gets upper, and then with the one we pivoted it, and then it looks something like this. So now you will see whatever the pattern we solved it in the previous, like here, it is same as here. Now if you have to know, like, what is the sum of the all the nodes that are present in this part. So for that, you'll have to find what is the answer for 1. What is the answer for 1? And the answer for 1 plus the nodes present in that subtree, if I add, then that would be the sum of the nodes from Ci, isn't it? So answer of Ci would be subtree answer of Ci that we have calculated in the above, plus subtree answer of inverse side of it, only the inverse side of it. So all the parts that are coming in this way, not the other way. Other way parts are already the sum is already counted for. So inverse side, how we calculate? So the inverse side would be answer of 1. So there is one beautiful thing. Answer of 1 is also a sub answer of 1. Answer of 1 is basically there is no parent node to 1. So there is no way we can go up. This CK has parents also, child also. So in this case, answer of CK is not equal to sub answer of CK. But for 1 it is equal. So we know the answer of C1. Answer of 1. Answer of 1 is basically, if you put 1 here, then that is the answer. So answer of 1 we know. Answer of 1 minus sub answer of Ci. So whatever is the answer of C1, let's say we know the answer of C1. Then we have to subtract the sub answer of Ci plus nodes in Ci subtree. So if we subtract, because this answer of 1 is constituted with the answer of C1, C2, Ci, Ck, and the nodes present in that subtree. So if I remove the contribution of this part, then I am left with answer excluding this part. So whatever there in this part, whatever there in this part, you see. So whatever there is in this part basically. Okay. And so these are basically the distances from one to all the other nodes. And n minus nodes in Ci plus subtree. This is because we have to calculate the distance from Ci. This is the answer from one only. This is the answer from one. Answer of So from one the distance are like this. From one the distances are like this. But if you want the answer from Ci, then we'll have to add the number of nodes present in this. So what is the number of nodes that is present is it? Then that would be difference of total nodes that is present in the tree minus nodes in the upper part of it. Number of nodes present in the upper part of it, then it would be give the. So answer of Ci would be something like that. So we know. So both the ways are like there are two parts of it. This is the solution for second part. Okay. So how we calculate the first part. First part is basically very simple. You take two arrays, uh, subtree size and subtree answer. So basically the subtree size would save the size of the tree that is present below including that node, and subtree answer would store the uh, answer of all the nodes that are present below that node including that node. So basically we start from this 1 comma 0. So this is basically the same thing you see, 1 2 3 4 5, and these are 1 2 3 4 5. So in the recursion it would be something like that. If you pass through these things, so you would understand. If you pass through the logic, the basically the code is in the description, you can see over there. So I have written a rough code of it. Okay, you can make it more readable or more logical. I have a very rough code over there, so feel free to kind of clean it. So here we see. So here we see what we have to do is basically, mm, for calculating the number of nodes, that is the sum of the distances of all the nodes that is present in that subtree. For calculating that, what we do is we go recursively and we hit the bottom case. The bottom case is that if we go at node number 4 and it does not have a child, so how many nodes it has? It has only one node, and sum is like how many child node it has who has some distance. There is no zero. Similarly, this is the case same for 5 also. One is the uh, sum of the nodes, and some of the nodes is zero, and one is the basically uh, it has only one uh, size. But when we recursively go back, uh, and when we calculate it for both the children, then what we see is what would be the size of 3. So size of 3 would be size of this and size of this plus 1. So plus 1 plus size of left side, size of right side is 3. So I put a 3 in the subtree size array 3. When we have to calculate the sum of all the nodes from this node, then the trick is, to the left child, calculate the subtree answer subtree answer of the left child, plus number of nodes on the left side. So subtree size is 1 and four is answer for 4 is 0. You see 4 is 0. Go to the right side. Subtree answer for 1 is subtree size for right side is 1 and answer for right side which is 5 is 0. So total sum is 0. So in 3 I would write 2. Okay. Similarly, it would be 1 only, the size would be 1 and the sum of the distances from this node because there is no node, so 0. But when we go back to this place, 1, so for 1 what would happen? On the left side, total sum is 1 plus left 1 and 3 coming from the right. From 3, size is 3. So these are, the first one is size and the second part is the sum of all the nodes from that particular nodes. One one is basically the one is basically this is two part of it. So for calculating sum of all the nodes from this node, we calculate it on the left side, we calculate it on the right side. On the left side, for calculation on the left side is add two things. First is the sum subtree answer, like what is the answer of it. So 0 is the answer. So this 0 is here and sum is 1. When we go to the right side, then it would be 3 is the answer. 3 plus 2. What is 3 plus 2? So 3 is basically the sum of the nodes on the right side. So on the right side, how many nodes are there? On 3, 3 is the, so we take it from here. So whatever we calculate on the previous step, we use on the next step. So 3 is the sum and 2 is coming from the subtree answer of 3. So subtree answer of 3 is 2. So we take it from there. Now it is 6. How did we put 2 here? We put 2 here from this calculation. This 2 came from 1 plus 1 contribution, that is from 1 and 0. So left plus right, if we add both these things, it would be 6. So I can just subtree answer is 6. So basically it says that under node 1, there are 6. Sum of all the nodes from node 1 is 6. And that comes to be exactly correct. So this is the way, and you know, like from one sum of all the nodes from 1 to all other nodes, you know. Similarly you would know for 3 also, similarly you would know for 2 also. So this is yeah, sum of all the nodes from nodes 3, answer is 2. Sum of all the nodes, that is 2 nodes, and this is the answer. So you know this. By using this, you can put this here to calculate the reverse direction also. Over there you just calculating for any nodes, you are calculating for sum of all the nodes that is below any node. But for calculating the nodes that are above that node also, you can calculate it. So the total answer would be answer of Ci. Answer of Ci would be the subtree answer of Ci plus inverse side of it. The best part is for answer 1, you have the sub answer is equal to answer is equal to sub answer, and you got the logic. So I have put this in the description. You can find this question. I have put the solution of it. So basically, so there is a input and output. We enter the nodes, 5 nodes, the edges, and I have printed like for 0 there is no node, for 1 there is 2 and 3, for 2 child node, these are child nodes, and size of the subtree, sum of the distances, and the final answer is this 0965. So you can just go through that logic. It is very poorly written, but you can use it. So there is only two best part of it. So first is calculating the sum of all the distances top to bottom. So this part, what I'm doing is, you have seen that I summed the sum of the children plus size of the children and put it into the sum, and this is for the size of the children. And once this pre-processing is done, then here what happens, the main part is that what happens is we know the answer of the leaf node, and then we go backward to the root of it. But in this code, we know the answer of the top root of it. So that is why it is starting from src. As you can see, this node is being called from 1. So 1 is already calculated. So 1 is already calculated, and now we are using the answer of src into the calculation of its root node with the same logic that I told. This is the logic. So you can fit into both this logic, and then you can understand. And let me know if you find this code helpful. If this find this is really a very difficult question. So bear with the difficulty of it, and try to understand it, and write the code of your own. So it would be helpful. Thank you.